This video is on graphing linear equations using the slope-intercept form of a line. It's part of a bigger series about graphing linear equations. You can click in the link below if you want to find the other videos in this series. So if you watched the other video in the series, we graphed a line using the table method, or also known as finding points, and then using those points to graph the line. So the finding points method or the table method is the method we used in the last video. Now we're going to use slope-intercept form of a line to graph the line. The basic understanding of how we do this is the following. We're going to put our equation into slope-intercept form. Once we have the slope-intercept form, we can identify the y-intercept, and so we're going to draw a point and start there. Then we identify the slope and use the slope to find the other points on the line, and then we draw the line. Now, slope-intercept form of a line is the following. It's the form that is y equals mx plus b. The slope is going to be the numerical value of m, and the y-intercept is going to be the point 0, b. So the b in this equation stands for the y value of the y-intercept. Some people will also say that b is the y-intercept. Other people like me use the point 0, b as being the y-intercept, but there are certain people who will call just b the y-intercept. So y equals mx plus b, where m and b are simply values, and then x and y are our variables. In our previous video, we looked at the line y equals 3x plus 4. This line was actually in slope-intercept form. Now, for this line, the slope is 3, and the y-intercept would be the point 0, 4. If we had filled out a table of values, what we would have seen is that when we plugged in the number 0 for x, we got the value of 4 for y. That's why our y-intercept always has to be this number. Because whenever you plug in a value of 0 for x, this term goes away, and you simply get y equals this number, and in general b. So we ended up with 0, 4. Obviously 4 is the y value of our y-intercept. Now, I want to explain slope a little bit before we get into this. What you'll notice here in this example is that the slope is 3. I've chosen points where the x value increases by 1 each time I go down. Notice that if I increase the x value by 1, for instance, going from -2 to -1, the y value goes from -2 to +1. That's an increase of 3. If I go from -1 to 0, the corresponding increase in y is 3. If I go from 0 to 1, the corresponding increase of y is 3. So this slope is telling me how much y is changing each time x changes by 1. And in general, what we think of that, we think of this as a change in y compared to a change in x. So like I hinted at, no matter what slope-intercept form we have, as long, whatever these numbers for m and b are, when you plug in 0, you get y equals b. So we're always going to get 0b as the y-intercept. We call it the y-intercept because it's going to hit the x-axis. I misspoke. We call it the y-intercept because it's going to hit the y-axis. So it hits the y-axis because it has x value of 0. This is the slope, the m. And like I was trying to hint at, m is considered the change in y over the change in x. So once we have the y-intercept, we can use the slope to find the next point by doing a change in y compared to a change in x. And we always think of the slope as a fraction, which is an improper fraction, change in y divided by change in x. So let's graph y equals 3x plus 4 using the slope-intercept form. The first thing we're going to do is notice that the b value is 4, so the y-intercept is the point 0, 4. Then we're going to notice that the slope is 3. So we have slope of 3, y-intercept of 0, 4. And those two pieces of information are all I need to graph. So what I would do is I would start at 0, 4, and the slope of 3, I'm going to think of as 3 over 1. That means I'm going to go up 3 and to the right 1. So I change the y value by 3 every time I change the x value by 1. So I start at the point 0, 4. I'd go up 3 and to the right 1 to get my next point. And then to get the point beyond that, I would go up 3 and over 1 again. And I could see that every time I need to go up 3 over 1, up 3 over 1, that gives me a few points. By the way, you could have also gone down 3 and to the left 1, because negative 3 over negative 1 is the same thing as positive 3 over positive 1. And we could have gone to the left as well. Once I have those points, I can simply draw the line and be done. Let's do example 2 on our own. So we have y equals negative 1/2 x plus 2. Now this equation is already in slope-intercept form. So we can take that equation and identify the slope and identify the y-intercept pretty quickly. In this case, my slope is -1/2. Now, when I think about that, remember, I want to think of it as a change in y over change in x. So when I write this fraction, that negative sign, I'm going to put in either the numerator or the denominator. I'm going to think of it as a -1 over a +2. That's going to be my change in y divided by change in x. So the y value is going to change by -1 each time the x value changes by 2. That's how we deal with fractions. When you have a fraction as a slope, we think of it like that. Now my y-intercept is going to be the point 0, 2. And with that information, that's enough to graph this line. So let's go ahead and graph this line. So here we go. We have our grid paper. Let's graph this. Again, we start at the y-intercept of 0, 2. 0, 2 is right there. So we draw a point. Let's actually make that point a little bit bigger just to emphasize what's going on. So there's our point, 0, 2. Change in y divided by change in x. A -1 change in y means I go down 1. A change in x of 2 is going right 2. Notice that I was really conscious about the fact that a negative in the y direction is down and a positive in the x direction is to the right. So -1 in the y direction goes down 1. Change in the x direction by a +2 goes to the right 2. I get another point. And I just keep this pattern up, down 1 to the right 2. Down 1 to the right 2. And I can keep going and going and going as far as my grid paper will allow me. Once I have that, now you can see the pattern of the line. So we simply need to connect those dots. And then, like I always do, I always draw arrows to signify that this pattern goes on forever. So there's the graph of that line by using the y-intercept and the slope. And we get that in a really efficient manner using the slope-intercept form of the line. Let's do another example. In this example, it asks us to graph 5x minus 2y is equal to -8. Now, it's pretty clear that this line does not fit our slope-intercept form as it sits right now. So we are going to manipulate this line into slope-intercept form before we can graph using the slope-intercept form of the line. Let's go ahead and do that. Now, getting an equation in slope-intercept form means I want to get y on one side and the x term and the constant term on the other side. So that means I would have to subtract 5x from both sides. If I do that, it's a different font size, I would get -2y is equal to -5x minus 8. Then I would have to divide both sides by -2. On the left-hand side, dividing by -2 would give me a y. On the right-hand side, when I divide by -2, -5 over -2 would be a positive 5 over 2 x. -8 divided by -2 gives me a plus 4. So we can easily see that the y-intercept is the point 0, 4, and also that the slope, which is m, is 5/2. I know I've mentioned this before, but I'll mention this again. Doing a positive 5 over a positive 2 is the same thing as doing a -5 over -2. So if you want to go in the other direction, you can think of the slope as -5 over -2 as well. When you're writing your answer in a learning management system, they might want the answer of 5/2. They might want it as a decimal. It depends on the learning management system. So now I know that the y-intercept is 0, 4, and that the slope is 5/2. So I can graph this line. The y-intercept being 0, 4 gives me the point up here. The slope of 5 over 2. That means I need to go up 5 and to the right 2 to get my next point. Now, obviously, my grid runs out of room after I fit 2 points. So if you're in this case, you might want to go in the other direction of down 5 and to the left 2. Notice that if you went down 5 and to the left 2, you'll get a point right here, which is on the same line. And if you wanted to go down 5 again and left 2 again, you'll get another point which is on that same line. So now we can see the pattern, and we will simply connect the dots with a straight line. And I like to write arrows at the end to show that the pattern goes on forever. So now I've graphed the line using the slope-intercept form, where we started with a line that didn't originally fit our slope-intercept form. Let's look at another example and graph this line. The line is 5x plus 3y equals 0. So once again, the line doesn't start out in slope-intercept form, but we will manipulate it to be into slope-intercept form. To manipulate this line into slope-intercept form, we're going to subtract 5x from both sides. Subtracting 5x from the left-hand side gives me 3y. Subtracting 5x from the right-hand side gives me a minus 5x, or a negative 5x. Then I would divide by 3. That will get the y alone on the left-hand side. When I divide by 3 on the right-hand side, I get negative 5/3 times x. Now remember, slope-intercept form is y equals mx plus b. And here we don't see the b because essentially our constant value on the right-hand side is a 0. So if we're trying to determine what the y-intercept is, the y-intercept is the point 0, 0, or the origin. The slope is -5/3, and you can either think of that as the fraction -5 over a +3, or as the fraction +5 over a -3. Either way will work. And in fact, we'll probably use both in this example. So if you don't see a value for b, that basically means that value has to be 0. So the y-intercept is 0, 0. When in doubt, you can always just plug in 0 for x and see what y value you get. Let's go ahead and graph using the information that I've found. Y-intercept is the origin, 0, 0. And if I'm looking at -5 over +3, remember that's change in y divided by change in x. So I need to go down 5 and to the right 3. -5 in the y direction is a down in the y direction. A +3 in the x direction is to the right 3. Again, if you want to do another point, -5, 3, I'd go down 5 more. And to the right 3 more. If you wanted to go in the other direction, in the left-hand direction, you'd think of it as a +5 over a -3. So +5 would go up in the y direction, 5 units. A -3 would go left in the x direction, 3 units. I may have misspoke there. Go up 5 in the y direction, go to the left 3, that's the x direction. And you can see you just get one line that shares the same features. So we draw our line. And then I usually, again, put arrows at the end to signify that this pattern goes on forever. So there, that's the graph of the linear equation that we saw earlier. That was 5x plus 3 equals 0. So that is the graph of that line, and we found that using the slope-intercept form. Let's do one more example. Here we want to graph the line y equals x plus 3. I already have y equals on the left-hand side of the equation. And so this is in slope-intercept form already. The only unique thing about this is that if you look at the coefficient of x, there is no coefficient, but we should know that the coefficient of x having no coefficient means that it's an implied 1. So technically the coefficient of x is 1. So when we go to get the important information from this slope-intercept form, we say the y-intercept is the point 0, 3, and the slope is 1. Now, anytime I have an integer slope, I want to think of it like a fraction, like a change in y over change in x. So many times people think of the slope as being 1 over 1. And if the slope happened to be, let's say, 7, we'd think of the slope as 7 over 1. Or if the slope happened to be negative 2, we'd think of it as negative 2 over 1. So any integer slope, we can simply divide by 1, and that gives us a way of understanding change in y divided by change in x. So integer slopes work that way. Now I have my y-intercept, I have my slope, so I can go graph this. Now, before I go graph this, let me just say another thing. If I wanted to go into the other direction, 1 over 1 is the same thing as negative 1 over negative 1. So I can also do negative over negative if I wanted to do that. I don't think I want to do that this time. So 0, 3 is the point up here. A slope of 1 means I go up 1 and to the right 1. I can continue that pattern, up 1 to the right 1, up 1 to the right 1. And I can do that as often as I would care to like. And if we wanted to think of this as negative 1 over negative 1, we could also move to the left. That would be down 1 and to the left 1, down 1 and to the left 1. And you can see you get the same line. All of these points are on my line. We obviously see the pattern there. So that is the graph of the line. I'll extend it forever in both directions. So there you go. Now we see this equation of the line. So that's how you graph in slope by using slope-intercept form. So again, when you step back and look at this from afar, the first thing you want to do is get your equation into slope-intercept form. We're going to identify the y-intercept and the slope. We start at the y-intercept, and then we use the slope to find other points, realizing that slope is always thought of as change in y over change in x. Draw the line, and then we're done. Now, there are certain lines that aren't easily put in slope-intercept forms, and we will look at those in the next video. There should be a link to that video in the description of this one. But any line that can be easily put into slope-intercept form or difficultly put into slope-intercept form can be done using this method. And hopefully you see the advantage to slope-intercept form is it's pretty quick. compared to the finding points method we did in the last video.